Hello, we're going to run through an example of how you might use Petal to write instructor grading scripts on a bunch of student submissions. Exact details will vary depending on the auto grading platform you're integrating with, but we'll be using the command line version here. So first things first, we need to install Petal, and since I have a fresh virtual environment here, that's as simple as just writing pip install Petal to get it installed. Excellent. All right, so now I can go and create a new blank file. We'll call it summatechecker.py. And this is where we're going to have our instructor control script logic. And I'm going to use this to have a auto-graded question where students define a function summate that sums up a list of values. It will look something like this when they're done. Now, going back to the instructor control script, the first things first, we need to import the Petal library. And this gives us access to a large number of Petal feedback functions and utilities, which we'll use to build a sophisticated instructor control script. However, by default, Petal already runs several tools to evaluate Petal students' code and provide feedback on syntax and runtime errors. So I can run the Petal feedback command on the summatechecker.py file and pass in the correct file from the students. So this tells the student in the output down here that they were correct. And normally this would appear through whatever auto-grading platform you're using, whether that's Gradescope or VPL or BlockPy or WebCat or whatever. But here we're just on the command line. Now, this instructor control script isn't very interesting since we don't actually have any logic that verifies they have the right answer. It's really just checking syntax and runtime issues. We can start off by checking something a bit more interesting by looking to see if they defined the summate function. And there's a few ways we could do this. We could write a static assertion using one of the built-in assertions, for instance, to find out if they've defined the function called summate. We could also enforce that they have the arity of 1, meaning that they must have at least one parameter. If we were teaching static type annotations, we could also force them to have certain parameter types and return types. But we're not going to do any of that, actually. We're instead going to show off a different feature called Kate. And this is a tool for flexibly searching the student's code simply by writing valid Python. So the instructor says that, oh, I want to recognize when the student's written a summate function that has anything inside of it. All they have to have done is define a function called summate. So we put that as an argument to our find match function, and that will return a match object. Either it will have found a function definition inside the code or it will not. If there's not a match, if the student didn't define the code, then we could give them some feedback using another one of the built-in feedback functions called explain. So we can say, you have not defined the function. And when we do that, we say that the label function missing is attached to this feedback object. This is useful for research and analysis purposes later on. If we want to come back to a bunch of student submissions and review them, we can get a bunch of statistics, and it would tell us that this feedback function was triggered a certain number of times. So it's helpful for us to organize our feedback from the beginning by attaching labels to it. Not necessary, but helpful. All right. Let's try running this on a student submission like this one, where they've defined the wrong function. They named it add up instead of naming it summate. So let me try running Petal feedback summate checker.py on this example, missing function.py. And you see that here we get the feedback message we previously established. You have not defined the function. Cool. So it's not enough to just have the function with the right name. We also need to call that function and make sure it produces the right result. And normally we would do that by writing unit tests. So in Petal, we can actually write statements like this, where we say, okay, assert equal that if we call the student's summate function, passing in the list 1 through 5, that it will produce the number 9. And there's a whole bunch of other assertions that we could have used. You see from this list just appearing here. And we could also use it in the old style of assert equal instead of the proper spelling assert equal. So either style works, and we have a lot of other options. Now, this safely calls the student's code, the student's function, and passes in the right number of arguments, ensuring the right value is returned. If they had not defined the summate function, or if they had a runtime error, then the instructor control script will handle that intelligently. It won't crash the control script. It will keep executing subsequent lines, and it will choose an appropriate error message for the student. So let me try running this on our correct student from before, and you see that they're still passing all of our test cases. Okay, so that sounds pretty good. What if the student had made a very small mistake? Like, what if they counted the number of items instead of having added the iteration variable? So they added 1 here instead of v, the way they're supposed to. Let's try taking that same script from before and running it on count versus sum.py, making sure that we save our instructor control script first. Cool, and you see here the feedback that we get for the student. It's not referencing any errors in the instructor code. It's not showing a traceback or anything. It's saying, hey, I ran your code. This is all I did. This is all we need to show the student. The value of the result was 3, even though I expected it to be 9. So it's a very straightforward message without any fluff. So we have ways of checking correctness. We can start thinking of some trickier situations. For example, a common mistake that about 1/3 of my students make the first time they write a function is to try and reinitialize the parameters. See here on line 2, they've incorrectly overwrote those values before they were even used. And even worse, they're using the exact value from our unit tests. So if we didn't have any other tests, then it wouldn't detect that mistake. But here's where another built-in Petal feature can help. We've written a simple static analyzer named Tifa, and it's built in to the standard environment, that when you run student's code, it analyzes it for this kind of mistake, looking for incorrectly defined variables, variables that are overwritten, type changes, that kind of thing. And it's fairly sophisticated. So let's try running it on this overwrote params file. And you see the feedback message says the variable numbers was given a value, but numbers was changed on line 2 before it was used. One of the times that you gave numbers a value was incorrect. Tifa has a lot of conditions it can handle. You can customize its feedback. You can also just completely turn it off. If you don't trust it, if you don't want it to be involved in the student's feedback, then there are ways to suppress it entirely. Okay, so one more example. This time we're going to use Kate in a more sophisticated way. An issue that sometimes comes up with new students is that they try to incorporate the function they are defining into the body of the function, basically accidentally causing infinite recursion. So you see here they're calling summate, and they're in the middle of defining it. They haven't used an if statement. This isn't intentional recursion or anything like that. They just don't know what they're doing and think they can just get away with defining the function by calling the function. If only it worked that well in real life. So the way we're going to use this Kate feature is we're going to check to see if we got a match object, then does that match, does its wildcard body that we named express, does it have its own match with a function call to summate? So here we're doing a nested find. And when we find that students have called the summate function inside the body of that other function, we can explain, hey, you are doing recursion. Don't do that. And we'll even give it a label, once again, to let us come back and analyze it later. Use recursion. Okay. So if we try running it now, Petal feedback on the summate checker.py, and we use that on the examples for recursion.py, we get our nice little feedback message, you are doing recursion, don't do that. We could write a bit more explanation or guidance for the student, give them a hint, but this will suffice as a start. Okay, so at this point, I've made a lot of changes to my instructor logic in the script. So I should really run my old submissions and make sure that they are still correct. Petal has several different command line modes, and there's one called verify that, given a directory of reference submissions, like this examples folder that I have, checks that they output the right value. So if I go look at my correct.py file, you'll see that there is adjacent to it a correct.out file that I've already pre-generated. And it's the expected output from running the instructor control script on this particular correct.py file. Now, I have to have created these output files in advance for all my submission cases, but you can also just tell Pedal to generate the expected files if they don't already exist. So if I do pedal verify summate checker.py and I pass in the entire folder of examples and tell it to create any output, then it will do so. And you see, I've already previously created certain files, so it's not overwriting them. When I created the original version of this, it was saying that I used a period instead of an exclamation mark for my output. So if I want to go back and fix that period, then when I do so, I run it again, I'm now passing all of my test cases, so I can make sure that I don't have any regressions with my feedback. All right. So if I had more time, I'd show you some more of these examples, but I think this is enough to get you started. You see that we have some documentation and some more tutorials for you to go through. So if you want to, please do check out the rest of Pedal. We're very excited about its features. There's a lot more than just what we've shown you here. We really want to see how much we can push feedback and what we can do with instructor control scripts. So thank you very much.